So today's topic is stoichiometry. So what are the main topics, subtopics in the stoichiometry? One is mole concept. Second one is oxidation reduction concept. Empirical formula and molecular formula calculations. And equivalent weights. And numericals based on equations. These are the important topics in the stoichiometry, because this mole concept and equivalent weights are very much important in the subsequent chapters of the intermediate chemistry, and these two are useful in the subsequent topics also. Now let us come to the important formula in the mole concept. What are the important formula in the mole concept? Let us do that. Number of moles, calculation of the number of the moles. So weight by molecular weight. Number of molecules by Avogadro's number. Volume of the gas at STP. By gram molar volume. And molarity into volume in ml by 1000. And in case of gaseous state, N is equal to PV by RT. From this we can derive sub-formulas. What are the sub-formulas that can be derived from this? Weight of the substance is equal to number of moles into gram molecular weight. Number of molecules is equal to small n into capital N. What is n stands for? Avogadro's number. Volume of the gas at STP is equal to number of moles into gram molar volume. Number of atoms in a compound will be equal to number of molecules multiplied by atomicity. Number of molecules into atomicity. So what is number of molecules? Small n into capital N into atomicity. What do you mean by atomicity? Number of atoms in a molecule. Similarly, number of electrons in a compound is equal to small n into capital N into number of electrons in a molecule. Next, number of ions is equal to small n into capital N into number of ions furnished by each molecule. In all these formula, what is the common point? We have to determine the number of the moles, because while determining the weight of the substance, gram molecular weight for a given substance is constant, Avogadro's number is constant, gram molar volume is constant, and number of small n and atomicity for a compound is constant, and all these are constant. What is the variable in all these formulae? Number of the moles. So before going into for the calculation of the problems, what are the definitions for the gram molecular weight? What are the definitions for the gram molecular weight? Weight of Avogadro's number of the molecules. Weight of Avogadro's number of the molecules, or weight of 22.4 liters of the gas at STP. Weight of 22.4 liters of the gas at STP, or molecular weight is equal to density into 22.4. What do you mean by density? Weight of the gas at weight of the 1 liter of the gas at STP, or molecular weight is equal to 2 into vapor density. And density of the gas can also be calculated by the relation D is equal to PM RT. At any given conditions of pressure and temperature, density is proportional to the molecular weight. These are the important formula involved in the calculation of the moles and mole concept. After this, what is the other important point? Other important topic is oxidation and reduction concept. So what are the definitions for the oxidation? Oxidation, addition of oxygen or removal of hydrogen, loss of electrons, increase in the oxidation number, and what is the reduction? Addition of hydrogen, or removal of oxygen, or gain of electrons, or decrease in the oxidation number. Now, oxidizing agent, reducing agent, and reducing agent. What the oxidation is a phenomena. Oxidizing agent is a process, is a substance. What is oxidizing agent? Which has a greater tendency to gain electrons. That is, oxidizing agents by gaining electrons will always undergo reduction. For them, oxidation number decreases. And reducing agent which has a tendency to lose electrons. By losing electrons, reducing agents always undergo oxidation. For them, oxidation number increases. What are the other how to identify in a set of compounds, how to identify oxidizing agents in a compound? When the central atom is in its highest oxidation state, such compounds always function as oxidizing agents. For example, KMnO4, K2, Cr2O7. In this, the central atoms are in their highest oxidation state. And oxidizing agents are also characterized by high SRP values. Higher the standard reduction potential values, stronger is the oxidizing agent. And reducing agents, how to recognize the reducing agent? When the central atom is in its lowest oxidation state, such compounds always function as the reducing agents. And reducing agents possess lowest SRP values. In the periodic table, halogens form the strongest oxidizing agents, reducing, and alkali metals form the oxidizing agents. Halogens form the strongest oxidizing agents, and alkali metals form the strongest reducing agents. Now coming to the, after this, what is the other important term? Equivalent weight calculations. Why equivalent weight has got such prominence? Because elements combine in the ratio of their equivalents. In any chemical combination, number of equivalents of substance 1, number of equivalents of substance 1 must be equal to number of equivalents of the substance 2. Number of equivalents of the substance 2. How do you get number of the equivalents? Number of moles multiplied by n factor. Number of moles multiplied by n factor. How do you get number of equivalents? Number of equivalents is equal to number of moles multiplied by n factor, where n factor is equal to molecular weight by equivalent weight. For an acid, n factor is equal to, for an acid, n factor is equal to basicity, and for a base, what is the n factor? Acidity. For an oxidizing agent, for a redox reagent, in redox reactions, what is the n factor? Nothing but change in the oxidation number. Nothing but change in the oxidation number. What are the ways to calculate the number of equivalents? Number of equivalents is equal to weight by equivalent weight, normality into volume in ml by 1000, volume of the gas at STP, volume of the gas at STP by gram equivalent volume, number of moles by number of moles into n factor, number of moles into n factor. These are the ways to calculate the number of the equivalents. These are the important formula involved in this chapter. The remaining thing we can discuss through the questions. Let us. Number of atoms in 4.25 grams of ammonia. So how do you get number of the atoms? What is the formula for the number of the atoms? Number of atoms is equal to small n into capital N into atomicity. Small n into capital N into atomicity. So what is meant by small n? Number of the moles. What is the way to calculate the number of the moles? Weight by molecular weight. Since weight is given, weight by molecular weight. What is n? Avogadro's number. What is the atomicity? 4. So number of atoms will be equal to n. Number of atoms will be equal to n. That is 6 into 10 to the power 23. The answer is choice number 4. Next question. Next, what is the next question? How many molecules? How do you get number of the molecules? Number of the molecules is simple. Small n into capital N. Here, to calculate the small n, which formula is to be used? Because what they have given, temperature, volume and pressure. Then how to calculate the number of the moles? N is equal to PV by RT. What is P stands for? 3 atmospheres. Volume is 1 ml, 1 by 1000 liters. What is R value? 0.0821 into temperature. What is the temperature? 27 degrees centigrade, 300. This is N. Multiply with 6 into 10 to the power of 23 will give us the total number of the molecules. So answer is choice number 3. What is the way to calculate the number of the molecules? Simple. Small n into capital N. And which formula is to be used to calculate the n value? It must be PV by RT, because what is the data given? Data contains pressure, volume and temperature. Before solving any numerical, what are 2 questions must strike to the mind? What is the information given in the problem? What is to be done? This is the question and this is the information given. Using this information, this is the way to solve the question. Next question. Now coming to the equivalent weights. What is the principle involved in the calculation of the equivalent weights? Number of equivalents of substance 1, number of equivalents of substance 1 must be equal to number of equivalents of the substance 2. Number of equivalents of the substance 2. Now what are the substance or element as the case may be? What are the elements here involved? Metal and hydride. Now number of equivalents of the metal, number of equivalents of the metal must be equal to number of equivalents of the hydrogen. How do you get it? Weight of the metal by equivalent weight of the metal must be equal to weight of the hydrogen by equivalent weight of the hydrogen. What is the weight of the metal? The total metal hydride weight is 0.84 grams. Weight of metal hydride is given as 0.84. What is the weight of the hydrogen given? 0.42. Then what will be the weight of the metal? Subtract it. 8, 9, 7. 0.798. This is the weight of the metal. Now applying in the formula, 0.798 by equivalent weight of the metal is equal to 0.042 by what is the equivalent weight of the hydrogen 1. Solving will get the answer. The answer is 4. That is equivalent weight of the solving the equation. We will get the answer as 20. Next question. Here also the same procedure. In this class, more emphasis is given for the equivalent weight calculation, because equivalent weight calculations are important in the senior inter topics, electrochemistry, as well as the solutions. That is why in this class more emphasis was given on the calculation of the equivalent weights, and equivalent weight calculations are also necessary in the volumetric analysis also. So what is the point here? Number of gram equivalents of the substance 1 must be equal to number of gram equivalents of the substance 2. What are the substances involved here? Metal carbonate and metal oxide. What are the substances involved in this chapter? What is the problem? 0.84 grams of the carbonate gave 0.4 grams of the metal oxide. So metal oxide. What is the way to calculate the equivalent weight of the metal carbonate? E plus 30. This will be E plus for metal oxide. Equivalent weight is E plus 8. Now what is the weight of the metal carbonate? 0.84 by E plus 30 by 0.4 by E plus 8. Solving, we get equivalent weight of the metal. Now what is the question given there? Specific heat of the metal, specific atomic weight of the metal is equal to equivalent weight of the metal into valency. And what is the other formula for the calculation of the atomic weight of the metal? Atomic weight of the metal, atomic weight of the metals, 6.4 into specific heat. Six 6.4 into specific heat. Next, what volume of 1 molar NaOH solution should be added to 12 grams of sodium hydrogen phosphate of molecular weight 120 to exactly convert into trisodium phosphate? Here also the same thing. Here also the same thing. Number of equivalents of sodium hydroxide, number of equivalents of sodium hydroxide must be equal to number of equivalents of sodium dihydrogen phosphate, NaH2PO4. How to calculate the number of equivalents for sodium hydroxide? N into V by 1000, N into V in ml by 1000. How to calculate this? Weight by equivalent weight, 12 by, for sodium hydroxide normality is equal to molarity, because sodium hydroxide happens to be the monoacidic base. So 1 into Vn ml by 1000. And what is the weight of that? 12. What is the equivalent weight of sodium hydrogen phosphate? It will be 60. 120 by 2. Calculating volume will be 200. Volume ml will be 200. Answer is 3. Because equivalent weight for sodium hydrogen phosphate is 120 by molecular weight by 2, that is 60. So on solving, volume will be 200 cc. Next question. Now this is a 12 liters of hydrogen, 11.2 liters of chlorine are mixed, and 12 liters of hydrogen and 11.2 liters of chlorine are exploded. And what will be the composition of the reaction mixture? How do you get volume of the mixture after the reaction? Volume of the mixture is equal to volume of the product formed plus volume of the unused gas, because volume of the product always depends upon the quantity of the product always depends upon the quantity of the limiting reagent. When more than one reagent is under consideration, the first step to be done is to identify the limiting reagent. What is the definition of the limiting reagent? The reagent which gets consumed up totally in a reaction is called limiting reagent. Then at the outset, how to recognize the limiting reagent? Simple. Determine the quantity of the product with respect to both the reactants. With respect to hydrogen, what will be the quantity of HCl formed? 12 liters of hydrogen can give rise to 24 liters of HCl, and 11.2 liters of chlorine can give rise to 22.4 liters of HCl. So we have determined the quantity of the product with respect to the hydrogen and chlorine. Which forms less quantity of the product? Chlorine. So ultimately chlorine must be the limiting reagent. The simple way to identify limiting reagent in a problem is to determine the quantity of the product with respect to both the reactants. The reactant which gives the less quantity of the product will be the limiting reagent. In this case, chlorine is the limiting reagent, and quantity of the product will always depends upon the quantity of the limiting reagent. So, in this case, since chlorine is the limiting reagent, the quantity of the product given by the limiting reagent will be the final quantity of the product. So, we will get 22.4 liters of the HCl. Now, what is the other reagent? Hydrogen is the excess reagent. What is the volume of the unused hydrogen? 11.2 liters of chlorine. 11.2 liters of chlorine can exactly combine with 11.2 liters of hydrogen to produce 22.4 liters of HCl. So, in the process, how much volume of hydrogen get consumed? 11.2, but available quantity of hydrogen is 12 liters. Volume of the hydrogen left unused is 12 minus 11.2, 0.8 liters, 0.8 liters. So, the final consumption, the final composition of the reaction mixture will be 22.4 liters of HCl and 0.8 liters of hydrogen. Option answer is 3. So, this is the simplest technique to identify the limiting reagent. Determine the quantity of the product with respect to both the reagent. The reagent that forms less quantity of the product will be the limiting reagent, and quantity given by the quantity of the product given by the limiting reagent will be the ultimate quantity of the product. So, in this case, chlorine is the limiting reagent, hydrogen is the excess reagent. What is the quantity of the hydrogen left over? 0.8 liters. Next question. 12 grams of an alkaline earth metal gave 14.8 grams of its nitride. Atomic weight of that metal is, so weight of the metal nitride is 14.8, and weight of the metal is 12 grams. Weight of the metal is 12 grams, and weight of the nitrogen is 2.8 grams. So, number of equivalents of metal must be equal to number of equivalents of nitrogen. So, 12 by equivalent weight is equal to, what will be the equivalent weight of the nitrogen? 14 by 3. Solving this, equivalent weight of the metal is 20. Equivalent weight of the metal is 20. Since it is an alkaline earth metal, what will be its atomic weight? Its atomic weight will be 20 into 2, 40. 20 into 2, it is 40. Next, option 3. Now, this is also volumetric analysis. This question related to the volumetric analysis. Here, what are the substances that are involved? Hypo and copper sulfate. Number of equivalents of hypo must be equal to number of equivalents of copper sulfate. Here, what is how to get it? 100 into 0.1 by 1000. must be, what is that, number of equivalents of hypo, it will be 0.01 equivalents, 0.01 equivalents, 0.01 equivalents. So 0.01 equivalents of hypo, 0.01 equivalents of hypo can exactly react with 0.01 equivalents of copper sulfate. In the iodometric reactions, so number of equivalents of copper sulfate will be equal to number of moles multiplied by n factor, So here number of moles n factor is equal to 1, Therefore, number of equivalents of copper sulfate will be equal to number of moles of copper sulfate, which is equal to 0.01. So weight of copper sulfate will be equal to number of moles into gram molecular weight, 0.01 into 250, that is 2.50. Because why the n factor for copper sulfate in this reaction is 1? In this reaction, copper sulfate CuSO4 will be reduced to Cu2I2. So what will be the change in the oxidation number for copper in this iodometric reactions? 1. That is why its n factor is 1. So number of equivalents of the copper sulfate must be equal to number of moles of the copper sulfate, which is equal to 0.01. How to get the mass of the copper sulfate? Number of moles into gram molecular weight, which must be 2.5 grams. Option is 3. Next, this question is related to the empirical formula and molecular formula. What is the way to find the empirical formula? Empirical formula is obtained when atomic ratio is simplified. What do you mean by atomic ratio? How do you get atomic ratio? Percentage weight of the element by atomic weight, or weight of the element by atomic weight. So after getting the atomic ratio, on simplifying it, we'll get the empirical formula. Here what are the elements there? Carbon and hydrogen. What is the percentage of the carbon? 86%. So how to get the atomic ratio? 86 by 12 and 14 by 1. So it will be simply 1:2. So empirical formula is CH2. What is given? 488 ml of the hydrocarbon. 488 ml of the hydrocarbon weighs 1.68 grams. 1.68 grams at STP. Then find the molecular weight. How do you find the molecular formula? Empirical formula into N. Where N is equal to molecular weight by empirical formula weight. What will be the molecular weight? How to calculate the molecular weight? 488 ml weighs 1.68 grams. 22,400 cc weighs how much? So 22,400 by 488 488 into 1.68. This is the molecular weight. This is the molecular weight. So molecular weight when divided with N is equal to molecular weight divided by empirical formula weight. What is the empirical formula weight? 14. We'll get the answer as 6. Then molecular formula will be CH2 into 6. CH2 into 6. It will be C6H12. So the compound must be alkene. The hydrocarbon must be alkene. What is the way to find the molecular formula? Empirical formula into N. So how to get the N value? Molecular weight by empirical formula weight. Molecular weight by empirical formula weight. How to get the molecular weight? 488 ml will weigh 1.68 to 22,400 cc weighs how much? This molecular weight comes to 84 grams. Empirical formula weight is 14 grams. N is equal to 6. Therefore, molecular formula will be C6H12, which is identical with alkene. Next question. So this is also can be solved. This is a problem based on the volumetric analysis. What is the total number of milliequivalents of HCl taken? Total number of milliequivalents of HCl taken is equal to 20 into 0.1. 20 into 0.1. 2 milliequivalents of HCl are taken. 2 milliequivalents of HCl are taken. Now, what is the number of milliequivalents of AgNO3 taken? Number of milliequivalents of AgNO3 taken. 10 into 0.11. So, number of milliequivalents of AgCl, number of milliequivalents of HCl leftover, number of milliequivalents of HCl leftover will be equal to 2 minus 1. So number of milliequivalents of HCl leftover must be equal to number of milliequivalents of NaOH. Number of milliequivalents of NaOH, which must be equal to 1. How to get number of milliequivalents? Number of milliequivalents of NaOH is equal to normality into volume in ml, which must be equated to 1. What is the normality? 0.1 into V must be equal to 1. Therefore, volume in ml is 10. That is the answer. So once again, what is given here? The number of milliequivalents of HCl is 2. How much AgNO3 is used? 1 milliequivalent. Then how much of HCl will be left over? 1 milliequivalent. 1 milliequivalent of HCl will require 1 milliequivalent of NaOH for the neutralization. So number of milliequivalents of NaOH must be mathematically normality into volume in ml must be equated to 1. So 0.1 into V. So volume is 10. Next, number of moles of KMnO4. Number of moles of KMnO4 required to oxidize 1 mole of FeC2O4 in acidic medium. This is a very important question. This involves. Now, what is the point here? Number of equivalents of KMnO4. Number of equivalents of KMnO4 must be equal to number of equivalents of ferrous oxalate. Number of equivalents of ferrous oxalate. How to get number of milliequivalents? Number of moles into n factor of KMnO4. Number of n factor of KMnO4 into number of moles of ferrous oxalate into n factor in acidic medium, KMnO4 changes into, in acidic medium, KMnO4 changes into Mn plus 2, so N factor will be 5. For KMnO4, N factor is equal to 5. But for ferrous oxalate in acidic medium changes into Fe plus 3 plus CO2. In this, for iron, change in oxidation number, change in oxidation number is 3 minus 2 into 1. For carbon, change in oxidation number is equal to 4 minus 3 into 2. So total change in oxidation number is equal to 3. 1 plus 2, 3. So in ferrous oxalate, what happened? 2 species has undergone oxidation. In such case, we have to add the change in, to get the final N factor, we have to add the change in oxidation number for iron as well as change in the oxidation number for carbon. What is the total change in the oxidation number for ferrous oxalate? It is 3. So N factor for ferrous oxalate is 3. N factor for KMnO4 is 5. Now just substitute. What is the number of moles of KMnO4? It is N into 5. What is the number of moles of ferrous oxalate used? 1 into 3. So N is equal to 3 by 5, which must be equal to 0.6. So answer is 1. This is an important concept. In a compound, if more than one species undergoes either oxidation or reduction, the N factor must be sum of the change in the oxidation numbers of both the elements. It is an important problem. Next. This is the maximum amount of barium sulfate mixed, precipitated on mixing equal volumes of barium chloride with H2SO4. This is also a problem pertaining to the limiting reagent. It is a problem pertaining to the limiting reagent. BaSO4. So what is the question? What is the equation? BaCl2 plus H2SO4, BaCl2 plus H2SO4, BaSO4 plus 2HCl, BaSO4 plus 2HCl. What is the quantity of the BaCl2 taken? 0.5 molar, and this is 1 molar. What is the limiting reagent? Barium chloride, because here number of moles of barium, number of moles of Ba plus 2 available, is 0.5 by 2, that is 0.25. Why it is divided with 2? Because equal volumes are mixed. When equal volumes of barium chloride and H2SO4 mixed, the concentration will be reduced to half, and number of moles of SO4 minus 2 available, SO4 minus 2 available is 1 by 2, 0.5. So what is the limiting reagent here? Ba plus 2. So 0.25 moles of Ba plus 2 combines with 0.25 moles of sulfate ions to form 0.25 moles of barium sulfate. That must be the answer. Next. Here this is the problem relating to the limiting reagent when equal volumes are mixed. Next. The hydrogen phosphate of a certain metal has the formula of MHPO4. MHPO4. The valency of HPO4 is 2. Therefore, the valency of metal must be 2. The metal must be 2 because HPO4 carries 2 units negative charge. So, the valence of HPO4 must be 2. Therefore, the valence of the metal must be 2. What will be the formula of the metal chloride? The valence of the metal is 2. The valence of the chlorine is 1. So, the formula of the metal chloride must be MCl2. Option 2. Next. What is the molecular mass of the acid? Molecular mass of the acid. This is the question. Molecular mass of the acid is equal to equivalent weight of the acid. Equivalent weight of the acid multiplied by basicity. What is the basicity here? What is the basicity here? Basicity, they have given it as a 2. Solid dibasic acid. So, number of equivalents of the acid must be equal to number of equivalents of the base. 1.25 by equivalent weight. And barium hydroxide, for barium hydroxide they have given the molarity, it must be converted into normality. 0.25 into 2, and what is the volume? 25 by 1000. So, solving it, what will be the equivalent weight? What will be the equivalent weight? We will get the equivalent weight of the acid as 100. Equivalent weight of the acid is 100. Then molecular weight of the acid. Molecular weight of the acid must be equal to 100 into 2, 200. The number of moles of BaCO3 which contains 1.5 moles of oxygen atoms, 1 mole of BaCO3, 1 mole of BaCO3 contains 3 moles of oxygen atoms. 3 moles of oxygen atoms. From the formula, 1 mole of BaCO3 contains 3 moles of oxygen atoms. 1.5 moles of oxygen atoms will be present in 0.5 moles. Will be present in a 0.5 moles. Option is 1. Next. The empirical formula is CH2. Mass of 1 liter. Mass of 1 liter of the compound is equal to mass of 1 liter of the nitrogen. What does it imply? Molecular weight of the compound must be equal to molecular weight of the empirical formula is CH2. Empirical formula is CH2. What is given? Weight of 1 liter of the hydrocarbon. Weight of 1 liter of the hydrocarbon is equal to weight of 1 liter of the nitrogen. 1 liter of the nitrogen under similar conditions of temperature and pressure. Under similar conditions of temperature and pressure. Therefore, weight of 22.4 liters of hydrocarbon at STP will be equal to weight of 22.4 liters of nitrogen at STP. Therefore, gram molecular weight of the hydrocarbon will be equal to 28. Then N is equal to molecular weight by empirical formula weight. So 28 by 14, it is 2, and molecular formula will be C2H4. molecular formula will be C2H4, option 1. Next, this is a problem based on the percent of purity. Percent of purity can be calculated in two ways. Percent of purity, percent of calculation of percent of purity based on the yield of the products. Based on the yield of the products is calculated as follows. Percent of purity is equal to experimental yield by theoretical yield into 100. Experimental yield they have given, what is that? 1120 cc. So what is marble? CaCO3 gives rise to CaO plus CO2. So 10 grams of CaCO3 should give rise to 2240 cc of carbon dioxide at STP. This is the theoretical yield. But what is the experimental yield? Percent of purity is equal to, what is the experimental yield? 1120. What should be the theoretical yield? 2240 into 100. It is 50% pure. It is 50% pure. 50% pure. Next question. 20 cc of CO2 is passed over. This is CO2 plus C gives us to 2CO. So 1 cc of CO2 will give rise to 2 cc and 20 cc will give rise to 40 cc. 40 cc, option 4. Next, air contains 20% of oxygen by volume. The volume of the air needed for the complete combustion of 100 cc of the acetylene. What is general equation for the CXHY plus X plus Y by 4 O2? X plus Y by 4 O2 gives rise to XCO2 plus Y by 2 H2O. Here based on this, C2H2 plus 5 by 2 O2 gives rise to CO2 2CO2 plus H2O. This is the equation. So 100 cc of acetylene requires 1 cc of acetylene requires 5 by 2 cc of oxygen. 5 by 2 cc of oxygen. 100 cc will require 250 cc of the oxygen. But we are asked to calculate the volume of the air. So what is the percentage of the air oxygen in the what is the percentage of the oxygen in the air? 1000 cc of air contains 200 cc of oxygen. 200 cc of oxygen. For us, what is the required quantity of the oxygen? 250 cc. 250 cc of oxygen is present in 1250 cc of air. 1250 cc of air. This is also simple number of equivalents of the point. 1 gram of hydrogen is found to contain. The step 1 is number of equivalents of Br is equal to number of equivalents of hydrogen. So AT by equivalent weight is equal to 1. Here equivalent weight of the bromine is equal to 80. In this step 2, number of equivalents of the bromine must be equal to number of equivalents of the calcium. Number of equivalents of the calcium 4 by 80, 1 by equivalent weight. So from this, equivalent weight of the calcium is 20. Option 2. So remaining part will continue in the next class.